All right, cool. So we're talking about slope today. Slope is really just an application of the constant of proportionality when we're working with proportional relationships. Okay? We are not always going to be working with proportional relationships, but in 7th grade we focus primarily on proportional relationships. When you think of slope, what comes to mind?
Like a mountain slope.
What'd you say? Yeah, Brennan. Down slope, what do you mean?
Like on a mountain. Like we like
going down
going down like
a mudslide kind of.
Mudslide, you're saying?
Ski slope.
Ski slope? Somebody said something over here. What was it? What'd you say? Yeah. Posture, okay. Distance, all right. So when I think of slopes, I think of skiing. Right? When I think of slope, I think of a roof. Sledding, right? If you're sledding, do you want the slope to be little or big?
Big.
Why? Because the bigger the slope, the steeper the angle, right? Smaller the slope, the more boring your sledding experience is, right? And that's kind of what slope is, all right? So let's get this written down. Slope is the rate of change between any 2 points on the line. It's the measure of steepness. So slope is related to the constant of proportionality when we're working with proportional relationships, okay? So in a proportional relationship, the slope is tied to the constant of proportionality because the constant of proportionality is a ratio of y to x. This is similar to that. It is not the same. Similar, but not the same. So to find the slope, you find the ratio, and this is the key difference, of the change in y over the change in x. What that means is how high it goes vertically compared to how high it goes horizontally. Slope is related to constant proportionality because you have y over x. But the slope is not y over x. What is slope? It's the what?
the rate.
No, literally I want you to read it. The change in y over the change in x. So if you start off at this point, and then you go up to the next point, you are measuring the change in y over the change in x. So I don't actually like to draw my slope triangle like the textbook draws its slope triangle, okay? I like to think of this, I want you to add this into your little box of information that's there. Slope is the change in y over the change in x. It's also the rise. So whenever I think of the change in y, I think of the rise, right? How high something is rising. And so I like to draw my slope triangle like this. See that? I like to draw the rise first. Rise is how high something goes up or goes down. Then I draw the run. So I'm going to draw that. My slope triangles typically look like this. Now I'm mentioning this thing called slope triangle. Well, because there's a triangle here. Do you see it? My slope triangles typically have the rise first and the run second. Because that way I remember. The rise is the change in y, so how high something is going up compared to how far something is running. Now this is new, so you might be like, what? Well, it's new, so bear with me, okay? This is a new idea. I'm introducing something new. And this is called slope. We remember slope as the rise over the run. Everybody remember rise over run. Say rise over run.
Rise over run.
Good, so you're on the pot, right? Enjoying a nice, relaxing BM. And you hear your phone ringing. What do you have to do? Can you run? You're on the toilet. You're gonna have, okay, how about this? You're taking a nap. You're taking a nap. Dreaming dreams. Bieber singing songs to you. Fine. Someone else is singing songs to you. Justin Timberlake is dancing in the background, making your life incredible. And then you hear your phone ring, boom! What do you have to do? You're taking a nap. What do you do first? Oh, you have to get up. And then you can run to your phone, right? Can you, so you're taking a nap, right? Can you run to your phone before you get up out of bed? No, you'd be like, ugh, right? I'd fall over. You can't run before you rise. Think about it. Taking a nap. So what do you got to do first? You have to rise out of bed. And then you can run to catch your phone. Vampires, right? They're taking their naps in their coffins. What do before they go run and wreak havoc on the world? They rise from the dead. and they run to their victims. Okay? So we have to remember to rise before we can run. Think about it, right? You're going to the pot, right? Better pull those pants up before you run. Otherwise, you're going to trip and fail. I mean, trip and fall. Right? So you got to rise and then run. So rise first, then run. That's why I like to draw my slope triangles like this. Rise first, run second. Yes? Yeah, ma'am. So here are some quick examples. Here are some quick examples. I say quick because I only want to spend a couple minutes on it. Just find the slope of each line. Well, I need to start at a point. So here are my instructions. You have them on your notes. Choose one of the points. I typically try to choose the point on the left. Try to start on the left. So I picked this point right here. There it is. The origin, nice to start from, right? And then I rise. How far do I rise? How far did I rise? How many units? So I drew that line. How many units is long is that line? 4. So my change in y from the first point to the second point, my change in y is 4, right? So 4. And then my run, I run over to the other problem. How many units did I travel? 3 units. So my run is 3. So my slope is 4 over 3. Now I told you that this is related to your constant proportionality. When the line is a proportional line, your slope and your constant of proportionality are the same. Only for proportional relationships. We're going to focus on proportional relationships for now. Question?
You wrote 2 to start.
Try. Thanks. I was supposed to say try to start on the left. Thank you. Let's look at the next one. So we write a slope as a fraction. That's the key. You have to leave it as an improper fraction. Okay? Let's look at letter B. So I start here. Try to start on the left, right? And then I rise up to the next point. How high do I have to rise? 1, 2. Oh, there it is. 3. So my rise is 3. And then I run 1, 2, 3, 4, 5, 6. So my run is 6. 3 over 6 is not simplified, so my slope is 1/2. Questions? Yes?
Why would you go up 3?
Because I'm trying to find the change in y over the change in x. That's the change in y between the points. So you notice the first point is down here. The second point is up there, right? I should just use this. Pop, pop. So I'm going from here to there, right? Now, if my slope is 1 over 2, that means my rise is 1 over 2. I bet you there's another easy to find point that's 1 up and 2 over. Do you see it? 1 up and 2 over. Hey, look at that. I'll bet you there's another point that's 1 up and 2 over. 1 up, 2 over. There it is. You can find the slope between any of the points, and it will give you the same slope. Just like how we saw with constant proportionality, we could find the constant from any point. All right, I want you guys to try them. Notice on number 2, and counting by 2s. You see that? This is counting, x is counting by 1s, y is counting by 2s. Talk to your neighbor about it. Go. Figure out the slope. Just use the definition. Draw your slope triangle. Don't pretend you know what you're doing. Draw your slope triangle. Just draw it and count. Draw it and count. My slope triangle usually rises first, runs second. Yep, 1 and 2. Notice number 2 counts by 2s, so be careful. Another way you can do it is look at the points. Look at the y values of the points. Look at the x values of the points. That's another way you can look at it. You can also look at the points to decide what is the change in y, what is the change in x. Yep. What's up? Just draw the triangle. just like we did, and count the number of spots you moved. You're just drawing and counting, everybody. All you're doing is drawing and counting. All right, check yours with mine. So how many people put 3 over 2 on this one? Don't raise your hands, just careful. The x's are counting by 1s. The y's are counting by 2s. Another way that you can check it is just look at the points. How far away is 6 from 3? How far, what's the change in y? So what are the y values? 3 and 6, right? What's the change in y from 3 to 6? 3. What's the change in x from 1 to 2? So 3 over 2. Excuse me, 3 over 1 is 3. Let's look at these points. What's the change in y from 0 to 2? What's the change in y from 0 to 5? So it's rise over run, change in y over change in x is 2 over 5. So that's another way you can look at it. If you're struggling with drawing the slope triangles and counting, just look at the points. Figure out what is the change in y, what is the change in x. Now we're going to look here on this data. And here we're given a table, right? Here, notice, this is the x and this is the y. So we need to graph it. So the x, this is 0, 0. This one is 2, 10. This one is 4, 20, etc., right? So we plot these. And then it says, find the slope of this line. Well, you can find the slope between any 2 points on the line, and it should be constant. Did you guys write down that as the definition? It is the rate of change. One thing you might want to add in there is that it is the constant rate of change. Something you might want to add in. Slope should be constant, which means that any point on this line, my slope should be the same. So here, the change in y from 20 to 40, what is that change? 20, right? What's the change in x from 4 to 8? 4. So my slope would be 20 over 4. Well, let's try it with a different set. Where do you think would be a really easy place to start? Where would be the easiest place to start counting from on this graph? Literally the easiest place to start counting from. 0. Isn't that the easiest place to start counting from? Okay, so how high do we rise here? How do we rise? 10. How far do we run? 2. So my slope is 10 over 2, which equals 5. Hey. Let's do one more. Let's go from this point. A little bit tougher, right? Let's go from here to the farthest point. So if I go there, how high do we rise from here, from 10 to 50? 40 spots. And then we count. 1, 2, 3, 4, 5, 6, 7, 8. And we get 40 over 8, which equals, wrong. There we go, 5. What do you see? That the slope is consistent. Now what does the slope mean? Well, it's the change in y over the change in x. Well, what's y? Dollars. What's x? So dollars per hour. So what does 5 mean? It means $5 per hour. Questions? All right, let's try one of our own. So in example 2, we used 2 other points to find the slope. Did we do that? Yes, we did. The graph shows the change you earn for babysitting. So here we go. Here's babysitting. You are the bottom one, your friend is the top one. Compare the steepness. What does that mean? All right, well, what does it mean? The blue one is steeper. The blue one is steeper. mean on the last problem? What did the slope mean over here? $5 per hour, right? Dollars per hour. So what is the slope on this one? Who made more money? Not made more money, but made more money faster. Not who is making more money. Not who's making more money, but who's getting paid more. Who's getting paid more?
Your friend.
What's your friend's rate?
$7 per hour.
$7 per hour? How'd you find it?
I did 28 divided by 4.
Good. Because this is a proportional relationship, the constant of proportionality and the slope are equivalent. So let's find it. Let's double check that. Let's compare the slopes. Okay? So the slope for my friend. How high do we rise? Not 30. How high do we rise? How high do we rise? 28. How far do we run? 4. So my friend has a rate of 28 over 4, which is $7 per hour. What's mine? Well, let's compare. Let's go here. How high do we run? 4. How far do we run here? 20. So, rise over run. Excuse me, I have that backwards. Realized I said that backwards. We run 4, we rise 20. Sorry about that. So our pay rate is $5 per hour. So do you guys see how similar slope and the constant proportionality are? Do you think you could write an equation for these?
Yes.
What would be the equation for my friend? Y equals what? 7x. What would my equation be?
Y equals
5x. So the slopes, find and interpret the slope of the blue line. What is that slope? It says that my friend makes $7 per hour. Slope is very similar to constant proportionality when we have proportional relationships. Now, there will always be a slope of a line, right? Big slope or little slope? Big slope or little slope? Little slope. Big slope, little slope. Big slope, little slope. Okay? So that's why this one, it's steeper, so it's a bigger slope. You with me on that? This one is not as steep, so it's a smaller slope. Okay? Your homework is this.